Hi, so I want to call these segments how to abuse tools as opposed to tips. Sometimes you want to join stuff, and we want to join a bit of pipe onto this. If I drill a hole and stick a pipe in there, it's going to be a bit of a nuisance. You want to flange on a piece of pipe like that. Now there's a really cool technique called metal spinning. And you can replicate it in your mini lathe with the aid of a blowtorch and a screwdriver. And all you really do is stick this in your lathe, turn your blowtorch on, jam the screwdriver at the end, and usually I use a posi drive, and just lever it out until you get your flange. Let me show you. So now we've got two and we're going to join them onto there, and having that flange means it's very much easier to sweat that onto the steel. So soldering, brazing, welding, they're just ways of joining metals that go up in heat, soldering being the lowest, brazing being the middle, and welding being the highest, obviously. Now normally you join like metal to like metal, so you're soldering copper together or you're welding steel, that sort of thing, you braze steel on steel. But you can join dissimilar metals, and when you do that it's called sweating. And what we're going to do is we're going to sweat some copper onto some steel because we need to join these pipes. Now, it's similar to soldering. Clean the metals, put on a flux, apply some heat. But with metal on metal, usually you're doing a bit of plumbing, you put the fittings together and you apply it that way. Can't do that with sweating. With sweating, you prepare one surface at a time. So you're going to sweat onto this hole here. So I've prepared it, I've cleaned it, now I need to flux it and solder it, and then do the same thing with this and apply some solder. So it's solder on solder. Then we put the two on and heat them, and those solders will flow into each other and give a good permanent joint, and that's a sweat joint. So let's do that. So that's it, a sweated joint, and it's actually a pretty strong joint for joining dissimilar metals. Anyway, I thought I would quickly go through that. Remember the key issues: keep it clean, do each side separately, and then heat the lower heating side and let it sink in. Hi, so currently I have two problems. I'm trying to drill an 18mm hole, and I'm trying to drill it through hard steel. And the problem is, I don't have a drill bit at 18mm, and that's something I find myself facing quite a lot actually. Now, I'm going to show you a little trick I use, and it uses the mini lathe and a Dremel with a hard grinding stone on it. Now, if you turn the mini lathe on and turn the Dremel on, the mini lathe will spin, the Dremel will spin, and as long as you're careful, because we're obviously using tools in a way they're not supposed to be used, you can grind that hole out beautifully. And you do it like this. And of course keep a micrometer handy so you can check the hole size, because it's very easy to go over. But it's a great way of getting holes in materials when the materials are hard to do and you don't have a drill bit to do it, which is something I find myself in, a state I find myself in constantly. So on the main channel I'm engaged in a project to make a steam turbine from a fan, and I've got this, which is a bit of hard tool steel. Now my little lathe, which is a mini lathe, meant mostly for mild steel, brass, plastic, that kind of thing, hasn't got a hope in hell of touching that. It might, if I'm lucky, polish it, but it really is not going to do it. So we're going to have to modify the tool, and of course I love doing that, hey? So we're going to modify it to be what's called a grinding lathe. Now grinding lathes are capable of incredible accuracy and meant for cutting this hard stuff that normal bits just won't cut, or they blunt in seconds. You'll find grinding lathes in industry, and they're actually remarkable things and very cool things. So let's modify our lathe to be a grinding lathe. Okay, that's it. There's my workpiece in the lathe, and I've stuck a fresh grinding disc onto my grinder, and all I'm going to do is hold the grinder against that. You could make a jig, that'll give you a great deal more stability, obviously. I've done this quite a lot, so I tend just to do it by hand. Now, you want a fresh disc because you want a square cut, and a job like this is not going to be terribly accurate, but I do have a pair of calipers handy so I can check it. And what I'm doing is I'm taking it down from 10mm to 8mm so it'll fit in this flexible couple. So the degree of accuracy I need is almost insignificant, okay? It's going to be miles out if it was an engineered piece, but it's going to be fine for this. However, grinding lathes are capable of incredible accuracy if you get a real grinding lathe. All we're doing is, because this is hard steel and we don't have a chance in cutting it because the job has got quite a lot of slack, the grinder held against that as both rotate, because both have to rotate, does an awesome job. Anyway, let's get some glasses on and switch that on. Okay, that's the job. Now, I was shooting for 8mm. I get it at 7.95, so that's not a bad job, and it's a nice smooth finish. But like I said, it's going on there, so there's plenty of slack in that, and that fits on there like that. So there you go, super simple. It does require a little bit of practice. A jig might help you, but if you have a lathe like me that you can't actually successfully cut these hard tool steels, great way forward. Hi, so I was thinking about this buy it or make it idea, and what we're going to do actually is make a drill bit. We're going to make a drill bit using a nail. Now it's just incredibly easy, eh? The nail obviously has a flat end and a pointed end. First things first, let's saw those off. Now we're going to flatten off the ends a bit. Then neaten up those flattened ends with a file. Then file it to a diamond point. So that's what it looks like. That angle can change. In modern drills it's 118 degrees, but in wood drills you can go to 75 degrees, so that the angle can actually change. However, that's roundabout right, it's fine. Now, when it turns in a drill, normal drills turn clockwise when looking from the top. So if we were to look from the top of the drill, which is down that drill shank, it will turn in a clockwise rotation, which is that way around. Now, when we come to sharpening the point, that bit needs to be the highest point, and we need to make that point lower. So let me do that and show you. And that's it. We've got a bevel going in that direction on that side, and the opposite direction. Drilling something soft, we could use that directly, but we can also case harden it, and case hardening is really easy. All we do, heat it to red heat, dip it in some carbon. That's graphite, but any carbon will do. 5 minutes of that, red heat, quench it, and you've case hardened it. So let's case harden this. Okay, so there's our drill bit in the drill. Let's give it a go. Sure enough, no trouble drilling a hole. So there you go, in a few minutes flat we made ourselves a drill bit that actually works. Now you might ask yourself the question, why bother? They're so cheap, just go out and get another one. Don't even bother sharpening it, just go and buy another one. And yeah, you could do that, and yeah, they are so cheap, why bother? Now, I don't actually like that use it, throw it away when it's broken attitude. I think you should know how to do these things. I don't think you should actually be bothered making drill bits, that's for sure, but I think you should know how to do it. The reason I think that is because it puts you at the mercy of others. If you don't know how to do something, you have to rely on other people, and that's all well and good, unless we have a problem. When we have a problem and you're at the mercy of others and you don't know how to do these things, well, you're lost. When you know how to do something, it puts you in the driver's seat. It makes you in charge of your own life, and it makes you the creative person. And that's what I think is important, is being creative, being in charge, being the master, if you like, of your own destiny and your own progress. Nothing wrong with going to buy stuff, perfectly fine. But having to do something, that's a different story. I think you should do things from choice, not because you have to. And I think knowledge gives you that choice. So, fun to know how they're made, actually fun to make them yourself. You don't need to, but I do think you need to know. Anyway, I hope you enjoyed seeing how a drill bit is made, and if you agree with what I'm saying here, thank you very much for watching.